All right, let's get started. So for our bell work today, we've got a couple of problems where we're finding the volume of a cylinder. So the first question is just write down the formula for the volume of a cylinder. So don't need to get too fancy. So we know that the volume of a cylinder, I better get a darker color here. Volume equals pi r squared times the height of the cylinder. And that pi r squared is basically the area of the circular base or end of the cylinder, and then the height is just this length right here, however long that is. So on our first one, we're going to have volume equals 3.14. So pi times the radius squared. So 10 squared, put a little parenthesis on there to keep that separated, and they're going to times that by 16. So while we're doing that, let's go ahead and do the other one. Let's get the other one set up. So on that one, the volume is going to be 3.14 times the radius, and in this case, we have a diameter of 3, so r is going to be half of that, which is 3. So 3 squared times the height, which is 18. Okay, so let's get our calculator going and figure out what these equal. So our calculator is right there. So 3.14 times 10 squared, and I happen to know that that's 100, times 16. So our first one is 5024 feet cubed, cubic feet. So that's pretty darn big, isn't it? That's a lot of volume there. Okay, for our next one, we clear out the calculator, then we do 3.14 times 3 times 3 times the height, which is 18. And so this one's going to be 508.68. So we're going to round that to 508.7. 508.7 meter cubed. Okay, let's check our answer, see how we did. Look at that, 524 cubic feet, 508.7, we are good. All right, let's move on. So today we're going to talk about how to calculate the volume of a cone and a sphere. So a volume of a cone, that's got a kind of an interesting formula, 1/3 pi r squared times the height. Take a little closer look at that. Watch these videos if you're at home, and there's a very good demonstration on why this formula is what it is. Okay, so here's a cylinder, and here's a cone of the same height, same radius. So you can see that the cone goes down to a point, whereas the cylinder stays the same radius all the way up. So the formulas for each of them are the same in that you have pi r squared times the height, pi r squared times the height. The cone formula is a little different in that you have to put the number 1/3 in front of the pi r squared times the height, because it turns out that the cone has 1/3 of the volume that the actual cylinder would of the same radius and height, as we saw in the videos. So based on that, so the formula is 1/3 of the base of the cone, which is pi r squared, times the height of the cone. All right, so let's try one. So find the volume of a cone. Round your answer to the nearest tenth. So we're going to get our marker going here. And we're going to have volume equals 1/3 times 3.14. So there's pi. R squared is 6 squared times the height, which is 15. So let's go ahead and multiply all of that out, get our calculator going. So we're going to do, and this is a little different than some of our calculators, but for 1/3, I'm going to do 1 divided by 3 equals, times that by 3.14, which is our pi value, and then times that by 6 squared. So times that by 6 squared, and that's all going to equal 37.68. And then the last thing is to times it by 15. So our answer is going to be 562.2 centimeters cubed. Let's check our answer, see how we did compared to the other one. Would you look at that? We got the same answer. Feeling pretty good about what we're doing so far. Okay, let's do another one. Now this one we already have a diameter across the bottom, so we know that in this particular cone, we're going to need to find the radius to use the formula, and the radius is going to be 2. So the volume is 1/3 times 3.14. So 1/3 pi times the radius squared. So 2 squared. And then times the height of the cone, which in this case is 6. All right, calculator time. Oops, calculator time. So 1 divided by 3 times 3.14 times 2 squared times 6. In this case, we got 25.1, and we are rounding this to the nearest tenth. That's why we got that. So it's meters cubed. Okay, quickly check our answer. How'd we do? 25.1 meters cubed. We are rolling. All right, let's keep it rolling. So here's one more. You're going to do volume. Okay, we're gonna go to pans. I'm sorry. So we got volume equals 1/3 times 3.14. So that we'd use that for every one of these particular formulas, times the radius squared, which is 9 squared, times the height, in this case 16. So I'll grab our calculator. We're going to have 1 divided by 3 equals, times that by 3.14 equals, times that by 9 squared, and that equals, and lastly, times it by 16. So we end up with 1,356. I hope we gotta take another quick look. 1,356.5 meters cubed. Check our answer. Looks good. We're just batting 1,000 so far. Okay, so here's a practical example of where you might use this. A company uses paper cups shaped like cones for its water cooler. Each cup has a height of 9 centimeters and a base has a diameter of 6 centimeters. The cooler has 12,717 cubic centimeters of water in it. How many cups can be filled from the cooler? So let's go ahead. What we're going to do is figure out the volume of a cup and then divide this number by that volume to find out how many actual cups of water we could fill with it. All right, so let's get started. So we got the volume of a cup is 1/3 times 3.14 times, so 1/3 pi times the radius squared, so 3 squared, because we have a diameter of 6, that means we got a radius of 3, and then we'll times that by 9. So when we calculate that out, we got 1/3 times 3.14 times 3 squared times 9. So it's 84 0.78. So now we're going to divide the big number by that number. So we're going to do 12,717 divided by that number, and then we should get our how many cups it'll take and how many cups we can fill with our cooler. So 12,717 divided by 84.78. Oh wow, look at that. We can fill 150 cups. Boy, that was a kind of a big number. I would have expected a little more than that. But each cup contains, 84, almost 85 cubic centimeters, so it eats it up pretty fast. Okay, let's try another one. Actually, we're ready for the volume of a sphere. So our last new item on the list. So if I had to find the volume of a sphere, like a basketball or a volleyball or any other spherical ball that you might be using, like those big medicine balls. So here's the formula. It's 4/3 pi times the radius of the sphere cubed. And when we say radius, we mean from the center of the cube or the sphere to the outside edge. That's the radius. All right. So 4/3 pi r cubed. And here's a couple of videos. If you're at home, take a look at these. They can kind of explain how that works. I think you'll find it very enjoyable. So 4/3 pi r cubed. Let's try a few examples. So here we are. We've got a volume with a sphere with a radius of 4. So the volume is 4/3 times pi, which is 3.14, times the radius to the third power. So 4 to the third power. In ways, this thing almost seems easier than the last formula, doesn't it? So let's get our calculator going. 4 to the third power would be just 4 times 4 times 4. And I'm kind of doing this backwards because that's a little easier in this case. Times 3.14. So times pi. And now to multiply it by 4/3, I'm going to times it by 4 and then divide it by 3. And there's my number. And then we want to round to the nearest tenth. So that's going to make this 267.9. So 267.9 centimeters cubed. All right, so there's our first one. I'll bet you if we check our answer that we got the right answer. Oh, look, they did 268.1. Okay, they must have used the actual number pi instead of 3.14 to calculate that. So we'll have to watch that on the next one. Okay, here's another one. We got a volume of a sphere. Round your answer to the nearest tenth. All right, so we'll try that on this one. So let's write it out. Volume equals 4/3 times 3.14 times the radius cubed times 4 to the third power. So we get our calculator. 4 divided by 3 equals that. Times that by 3.14. And then times that by 4 times 4 times 4. And so we end up with 264.5 feet cubed. Remember, these are all cubic units. Okay, so you kind of get the idea. Now, if you have a diameter like this, remember the radius would just be 6. Okay, so don't forget that. All right, so let's jump to one of our story problems. Let's see how many of those we have. We have one story problem, so let's just jump to that one. The manufacturer makes decorative globes out of silver in the shape of a solid sphere. Suppose each sphere has a radius of 4.5 centimeters. Okay, so we got a sphere down here. And we got to keep in mind that from the center of the sphere to the outside edge is 4.5 centimeters. And now we're going to use that to find the volume of our sphere. And then we can figure out how much it costs to make this sphere. So let's start out with 4/3 times 3.14 times the radius, which is 4.5 to the third power. And that's going to be the volume of this sphere. So let's use our calculator to find that real quick. Okay, there it is. So 4 divided by 3 equals times 3.14 equals. Okay, and then 4.5 to the third is going to be 4.5 times 4.5 times 4.5, just like that. And our amount is going to be 381.51. So 381.51 centimeters cubed. All right, so if the silver is priced at $4 per cubic centimeter, how much will it cost to make one solid sphere? So we're going to take this number, 381.51, and times it by 4. So get our number back on here, times it by 4. So this sphere is going to cost 1,500. I kind of missed that there. 526.04 centimeters cubed. No, this is a cost, right? So for this many cubic centimeters, it's going to cost this many dollars. So it's the units in dollars. Okay, well, good luck. These look like some fun problems, but they do not look that difficult, at least for you guys. So thank you very much.